One of the most remarkable things to happen to me in my life is to find myself associated with the Vatican Observatory. The Vatican Observatory is the Vatican's astronomical observatory. There is an observatory at Castel Gandolfo in Italy, which is a really pretty place. And they also have a telescope on top of Mount Graham out in Arizona. You know, I'm a professor at Jefferson Community and Technical College here in Louisville. As you can see on the screen, you know, shout out for Jefferson. Send your students. Actually, you have sent some of your students because I've had some Immaculata graduates in my class. I see somebody has an ECTC shirt around here somewhere, so that's okay too, right? You know, so it's Elizabethtown, you know. So, and so there are great things about Jefferson and about Louisville, but you know, I didn't come to Louisville and take this job. You know, I've been on the faculty at Jefferson since 1990. Didn't come here expecting to become a guy who does research and publishes articles and books, and ends up working for with the Vatican Observatory. And again, yes, Mr. Sawyer mentioned there's little sign-up sheets on your table. If you're interested in, basically, if you put your email address on there, you'll get an invitation to subscribe to the blog and stuff like that. So, which you can then decline if you wish. So you're only signing up to get an invitation. So I am one of the writers for the Catholic Astronomer blog, which is the blog officially of the director of the Vatican Observatory, Brother Guy Consolmagno. And as Mr. Sawyer said, I edit the faith and science pages. So this connection came about because I got interested in a question from the history of science. There's an observation that was found in Galileo's notebooks and first published in 2004 that did not really make sense. And then my students asked me questions that I had difficulty answering. And it turns out that the internet is a remarkable thing because it has made old, rare books available to anyone. Okay, if you wanted to dive through a library of 400-year-old books on astronomy written in Latin 25 years ago, you would have needed a very large travel budget, a lot of time, and access to a lot of exclusive libraries. Now you need a smartphone, okay, because most of those libraries have digitized their collections and put them online. So if you want to look at a copy of one of Kepler's works, original, you can find it online easily, very, very quickly. Quite a few of them are just on Google Books. All right. My work has been on what Galileo saw and what my students asked about and what can be found by reading old books. And what I found is that a key question in science did not unfold like we usually hear that it did. Basically, that between that time, back when we thought that science showed the Earth to be at the center of the universe, and now, when we think science shows the Earth to be orbiting a sun in a galaxy full of other suns, in a universe full of other galaxies, there's this time a brief time, where we thought that science showed the solar system to be in the center of an odd universe that was composed of stars that were not suns, but immense bodies, and every last one of them being over 1 million times the size of the sun as measured by volume. Today we know that stars come in a wide range of sizes, but most are red dwarfs that are smaller and weaker than the sun is. And anyhow, and this whole thing was supposed to be a testimony to the power of God. This sort of bizarre idea, which the telescope seemed to support, might well have been a key issue in the rejection of the ideas of Copernicus by many astronomers and by church officials. And that sort of history of science with a Rome connection eventually led to me making contact with Brother Guy Consolmagno, who is now the director of the Vatican Observatory. And over time, things grew from there. It's been amazing to be doing this research. It can be like living in a movie where you're peering through ancient documents, discovering lost knowledge. Sometimes I say we because my wife, Tina, who's sitting over there, has helped me a lot with translation, and now I have my son interested in this kind of stuff too. Okay, sometimes we just run into cool stuff. All right. For example, what I'm working on right now is stuff involving Johannes Kepler. And it seems that Kepler, who's the man who really made our modern view of the universe what it is, Kepler liked that immense stars, power of God idea. And yet he argued that despite all the immensity, Earth is still a cool place to be. So I'm going to read you something I translated just last month. Not a lot of people have heard it, and that's despite the fact that I read it to whoever I can corner and force to listen to it, like you guys. Okay, so this is Kepler talking about sizes. So he says, "Where magnitude waxes, there perfection wanes, and nobility follows diminution in bulk. The sphere of the fixed stars, according to Copernicus, is certainly most large, but it is inert, in no motion. The universe of the movables, that's the planets, is next. Now this, so much smaller, so much more divine, has accepted that so admirable, so well-ordered motion. Nevertheless, that place neither contains animating faculty, nor does it reason, nor does it run about. It goes, provided that it is moved. It has not developed, but it retains that impressed to it from the beginning. What it is not, it will never be. What it is not made by it. The same endures as was built. Then comes this, our little ball, the little cottage of us all, which we call the earth, the womb of the growing, herself fashioned by a certain internal faculty. The architect of marvelous work, she kindles daily so many little living things from herself, plants, fishes, insects, as she easily may scorn the rest of the bulk in view of this her nobility. Lastly, behold, if you will, the little bodies which we call the animals. What smaller than these is able to be imagined in comparison to the universe? But there now, behold feeling and voluntary motions, an infinite architecture of bodies. Behold, if you will, among those, these fine bits of dust, which are called men, to whom the Creator has granted such that in a certain way they may beget themselves, clothe themselves, arm themselves, teach themselves an infinity of arts, and daily accomplish the good, in whom is the image of God, who are in a certain way lords of the whole bulk. And what is it to us that the body of the universe has for itself a great breadth, while the soul lacks for one? We may learn well, therefore, the pleasure of the Creator, who is author both of the roughness of the large masses and the perfection of the smalls. Yet he glories not in bulk, but ennobles those that he has wished to be small. In the end, through these intervals, from Earth to the Sun, from Sun to Saturn, from Saturn to the fixed stars, we may learn gradually to ascend toward recognizing the immensity of divine power." Now, y'all, that is what is known as cool, okay? I got to read that and to sort of discover it, and now to share it with you just by doing some translation and taking seriously what Kepler had to say. There is so much in the history of science that is unknown. You think about how many historians study the Civil War. And the Civil War is what? 4 years plus build up to it and the Reconstruction after it, a few decades, okay, in one country. The history of science, and science is this immensely influential force in our society. The history of science covers thousands of years, and it's global. And yet there's very few people who study it. Most of Johannes Kepler's works, and Kepler is one of the A-list scientists in history, okay? Most of his works are untranslated. The first in-depth scientific study of an astronomical object is a study of the sun by Father Christoph Scheiner of Ingolstadt, Germany. It's untranslated, okay? I say this to you because I believe that Immaculata emphasizes classical learning and teaches Latin. I encourage you to consider looking at scientific works. It's not that hard. If I can do it, it's not that hard. You just have to know Latin and basic science and be really dogged and think that people in the past were not stupid. This school holds talks like this and takes out big ads in the Record. Yes, I saw that to my surprise, okay? You seem to want to do something beyond the norm. How about become the school that cranked out the first translation of Kepler's De Stella Nova? It is not any crazier than a professor at Jefferson Community and Technical College in Louisville, Kentucky, doing research and publishing articles and books and working with the Vatican Observatory. There's no telling what you might find. You might find something like Copernicus and the High Seas. This stuff is mostly not my research. I've added a little on this here and there, but that's all. But this is such a great story, and you've never heard about it, and you will find it hard to believe, and then you're going to share it with your friends after you hear about it. It's a sample of what is out there to be discovered in the history of science if people who know some Latin and some science will dig it up, all right? So, the title of that's sort of the introduction. The title of the talk is Copernicus and the High Seas. So, Copernicus, 1543 book on the revolutions of heavenly spheres. It's known for the heliocentric theory, the proposition that our world is a planet circling the sun. But the book also contains a discussion on the shape of our world and even a mention of America. There's a story behind this, a story that contains within it a very strange incidence of the intersection of science and religion, and it's one that I'm pretty much sure that you haven't heard of. Okay, and that's going to be the basis of this talk. So within Book 1 of On the Revolutions, Copernicus includes 2 chapters on the shape of our world. Chapter 2 of Book 1 he entitles The Earth Too is Spherical, and he writes, "The earth also is spherical, since it presses upon its center from every direction. Yet it is not immediately recognized as a perfect sphere on account of the great height of the mountains and depth of the valleys. For a traveler going from any place toward the north, that pole of daily rotation gradually climbs higher, while the opposite pole drops down an equal amount. More stars in the north are seen not to set, while in the south, certain stars are no longer seen to rise. Thus, Italy does not see the star Canopus, which is visible in Egypt." Now, Copernicus actually wrote in Latin, right? What I read you is English translation, but it's here, okay? Ita Canopum not seen in Italy, but Egypt. Okay, that's there. That's his original document, which of course can be found because all these things are digitized and now available on the web. It used to be really hard to get something like that. So, but even though, so this is an English translation, it probably sounds familiar to you. It's simple evidence for the roundness of the earth and why, contrary to popular myth, no one ever who bothered to look ever thought that the earth was flat. Ever. Okay. A little further on, Copernicus continues with, "The waters press down into the same spherical figure also, as sailors are aware, since land which is not seen from a ship is visible from the top of its mast. On the other hand, if a light is attached to the top of the mast as the ship draws away from land, those who remain ashore see the light drop down gradually until it finally disappears as though setting. Water, furthermore, being fluid by nature, manifestly always seeks the same lower levels as earth and pushes up from the shore no higher than its rise permits. Hence, whatever land emerges out of the ocean is admittedly that much higher." This is odd. Copernicus is discussing water separately from earth. It seems that what Copernicus means by the earth is actually just the dirt and rock stuff. That is, the earth stuff. And why state that the land is higher than the ocean? Duh, right? I mean, of course the land's higher than the ocean. Oh, hat change. All right. Uh-oh. All right, so following this discussion of the water comes chapter 3, entitled How the Earth Forms a Single Sphere with Water. This reads as follows. "Pouring forth its seas everywhere, then, the ocean envelops the earth and fills its deeper chasms. Both earth and water tend toward the same center because of their heaviness. Accordingly, there had to be less water than land to avoid having the water engulf the entire earth and to have the water recede from some portions of the land and from the many islands lying here and there for the preservation of living creatures. For what are the inhabited countries and the mainland itself but an island larger than the others?" This seems like a pretty straightforward description of our world. However, according to David Wooten, who devotes a substantial chapter of his 2015 book, The Invention of Science, to the question of the shape of the earth, Copernicus's description was contrary to a very common idea of his time. Indeed, the next thing Copernicus does is to address a subject that seems really strange. He says, we should not heed certain peripatetics, those are Aristotle enthusiasts, who declare that the entire body of water is 10 times greater in volume than all the land. They also assert that the earth bulges out to some extent, as it does, because it is not of equal weight everywhere on account of its cavities, its center of gravity being different from its center of magnitude. It turns out that there was a very strange idea floating around during the time of Copernicus. That idea was that the earthy stuff was one sphere, and it was partially enveloped by a sphere of watery stuff. Thus, the earth bulged out from the watery stuff like this. Right? So the dark part's the earthy, and the light is the watery. And that's, I don't really have the volumes quite right. There should be more water than earth, to be 10 times. So this is what's called the two spheres theory on the shape of the world. There had to be a lot more water than earthy stuff. Indeed, as Copernicus notes, according to some people, there was supposed to be 10 times as much volume of water as there were of earth. The earthy bulge included all the known terrestrial world, Europe, Africa, and Asia. The center of the terrestrial bulge was typically taken as being Jerusalem. Jerusalem is more than 30 degrees north of the equator. Jerusalem is at about the same latitude as Savannah, Georgia, or Shanghai, China. So if we look at the world aligned north-south, it would look something like this slide. So there's the North Pole, and then there's the bulge, and Jerusalem is in the center of the bulge. It's hard to imagine this strange-looking thing rotating daily about a north-south axis. So David Wooten notes that an important first step towards a heliocentric theory in which the world is rotating daily while it revolves around the sun is to get rid of this idea about two spheres being the shape of the world. To do that, Copernicus cites geography, and in particular the discovery of America. He writes that the two spheres theory is wrong, as can be established, he says, by the fact that from the ocean inward, the curvature of the land does not mount steadily in a continuous rise. If it did, it would keep the seawater out completely and in no way permit the inland seas and such vast gulfs to intrude. Of course, a devotee of this theory could counter the earthy sphere is obviously not a perfect sphere. It has high mountains and deep valleys. Copernicus noted this himself. If you had deep enough valleys in the earthy sphere at the point where it meets the watery sphere, that would allow for inlets and even for the entire Mediterranean Sea. That is, the Mediterranean means the sea that's in the middle of the lands. But Copernicus continues on. He says that if the two spheres theory, this theory, was correct, he said, the depth of the oceanic abyss would never stop increasing from the shore of the ocean outward, so that no island or reef or any form of land would be encountered by sailors on the longer voyages. Right? So, if the two spheres theory was correct, then as a ship sailed out from the shore of the ocean out toward A, then B, and then towards C, they would pass over deeper and deeper waters. So you would actually, the idea was the oceans were, hundreds, even thousands of miles deep out in the deep, deep ocean. So you would find no land outside of maybe a few coastal islands. So if the theory is correct, then a ship would sail out from the land into the ocean. Water would just get deeper and deeper. You might have some local irregularities that accounted for islands near the shore. But once you got out a certain distance, you should see no more land. Needless to say, the discovery of America shows that this isn't correct. All right. So Copernicus says new lands have been discovered in addition to the ones known by the ancients. He says these include the islands discovered in our time under the rulers of Spain and Portugal, and especially America, named after the ship's captain who found it. So he was wrong on that. Okay. On account of its still undisclosed size, it is thought to be a second group of inhabited countries. Indeed, geometrical reasoning about the location of America compels us to believe that it is diametrically opposite the Ganges district of India. So America's existence, discovered just 50 years prior to the publication of On the Revolutions, demonstrates that the two spheres theory cannot be correct. Copernicus concludes that our world must be the sort of body that we know it to be today. He says, "From all these facts, finally, I think it is clear that land and water together press upon a single center of gravity, that since Earth is heavier, its gaps are filled with water, and that consequently there is little water in comparison with land, even though more water perhaps appears on the surface." Right? "The Earth, together with its surrounding waters, must in fact have such a shape as its shadow reveals. For it eclipses the moon with the arc of a perfect circle. It is perfectly round, as the philosophers hold." So this is a photo of a lunar eclipse. You see the shadow of the Earth crossing onto the moon, and it's round Earth. Okay. So this sort of a world, a sphere of earth and water, is the sort of body that could rotate on an axis that runs from north to south. And Wooten argues that the discovery of America was crucial in overthrowing the two spheres theory and thus making it possible to think of a rotating planet Earth that circles the sun. Of course, not everyone adhered to the two spheres theory. For example, in the German National Museum in Nuremberg, Germany, is the Erdapfel, or Bohème globe, which dates to 1492. It shows the world with no America. Okay, there's just a big ocean that goes from Western Europe all the way around to Asia. And the globe is round, and it's got big, large Europe, Asia, Africa landmass. And it does not represent a two spheres theory type world. It represents something that could actually rotate. But it's clear that the two spheres theory idea had enough adherents that Copernicus felt the need to refute it. So, okay, we got the two spheres theory. Now, there's some really interesting ideas that spring up, so to speak, from the two spheres theory. Right? If the world is composed of two spheres of material, an earthy sphere and a water sphere like this, with the earthy sphere bulging out from the watery sphere, then how do you explain this? So there's a variety of ways that this was explained. Copernicus cites one in his book on the revolutions, the idea that the earthy sphere had cavities in it, and so it was just buoyed up by the water sphere. It floated. The Earth floated in the water. Wooten devotes a chapter on this in his Invention of Science and notes other ways. Okay, Wooten says one way of explaining it was this, that Wooten writes, the waters have been displaced from their original position and their sphere now has a center other than the center of the universe. This view implies that ships sail uphill as they sail out on the ocean. In 1320, Dante took this to be the standard view. In other words, if the center of the earthy sphere is the center of the universe, that is the lowest place in the universe, and if the water sphere is off-center to the earthy sphere, then it follows that some points on the water sphere would be farther from the center of the universe, that is higher than dry land. The ocean would be higher than the land. So here, points C and B on the ocean are both further from the center of the universe, which is in the middle there, and therefore higher than land. Okay, this is the idea of the high seas. Okay, that's where this is where we believe the phrase "the high seas" comes from. It's the idea that the seas were actually higher than the land. Now, this explains a natural phenomenon: springs. Okay, especially big springs, and especially big springs in the middle of a desert or high up on a mountain. What gets water gushing out of the side of a mountain? What gets water gushing up in the middle of the desert? Okay, especially out in the desert, in an oasis, there's no rain, right? Where would that water come from? Cracks in the earth. Okay, that allow water from the ocean to work its way through, and that water is under pressure and rises up from the ground owing to the fact that the ocean is higher than the land, and water seeks its own level, and that drives the water up out of the springs, even on mountainsides. Wooten notes that even after the discovery of America and the collapse of the two spheres theory, the idea persisted that the seas are higher than the land. So on the left here is an illustration of how in the two spheres theory, water from the watery sphere feeds the springs. So there's the center of the universe. This is higher than the land, and so the water is forced through and comes out in springs on mountaintops. All right, but on the right is an illustration of how, even under a more modern view in which the world is mostly earthy material with water in ocean basins on its surface, the ocean is still supposed as being higher at F than the land, and thus feeds springs at L. So the ocean's higher here, forces water up, comes out a spring over there. Now, these are from Gaspar Schott's Anatomia Physico-Hydrostatica Fontium ac Fluminum of 1663. This was an idea that people knew something about. For instance, in a book published in 1688 called Familiar Letters, Domestic and Foreign by James Howell, can be found a letter of April 1st, 1617, from James to his brother, in which he writes, "I am newly landed at Amsterdam, and it is the first foreign earth I ever set foot upon. I was pitifully sick all the voyage, for the weather was rough and the wind untoward, and at the mouth of the Texel we were surprised by a furious tempest. Having been so rocked and shaken at sea, when I came ashore, I began to incline to Copernicus his opinion, which hath got such a sway lately in the world, namely that the earth, as well as the rest of her fellow elements, is in perpetual motion. For she seemed so to me a good while after I landed." Right. "He that observes the site and position of this country will never hereafter doubt the truth of that philosophical problem which keeps so great a noise in the schools, namely that the sea is higher than the earth. Because, as I sailed along these coasts, I visibly found it true. For the ground here, which is all twixt marsh and moorish, lies not only level, but to the apparent sight of the eye far lower than the sea, which made the Duke of Alva say that the inhabitants of this country were the nearest neighbors to hell of any people on earth, because they dwell the lowest." Right. Okay, so though, if water seeks its own level, what keeps the oceans higher than the lands so that their waters feed these springs? Okay, why don't the waters of the ocean flow back over the land? The answer, the hand of God. All right. So, it's not that the seas being higher than the land or needing to be held out was a particularly Judeo-Christian idea. So according to Wooten, in The Invention of Science, Pliny the Elder wrote about this sort of thing back in the days of Caesars. And the idea of the seas being something that would inundate the whole world unless held back, that's something that shows up in different cultures. But it does not require too much imagination to see the two spheres theory in the words of Genesis. All right. God also said, "Let the waters that are under the heaven be gathered together into one place, and let the dry land appear. And it was so done. And God called the dry land earth, and the gathering together of the waters he called the seas." This is a Douay-Rheims translation, which is kind of appropriate to the time period. So the waters gathered together into one place, all right, matches the two spheres theory. Or in the Psalms, "Bless the Lord, O my soul. O Lord my God, you are very great. You are clothed with honor and majesty, wrapped in light as with a garment. You stretch out the heavens like a tent. You set the earth on its foundations so that it shall never be shaken. You cover it with the deep as with a garment. The waters stood above the mountains. At your rebuke they flee. At the sound of your thunder they take to flight. They rose up to the mountains, ran down to the valleys, to that place that you appointed for them. You set a boundary that they may not pass, so that they might not again cover the earth." That's a New Revised Standard Version translation. All right. And so you see, that's like the two spheres theory idea. You find it seems to be there in the Bible. And so now we get the strangest incident of the blending of science and religion. Here is a lengthy quotation from a sermon against atheism preached at the parish church of St. Martin in the Fields, November 24th, 1700, by Thomas Knaggs. So the bounds and limits, see, he writes this, the bounds and limits which are set to the sea, which by a perpetual decree it cannot pass, may let us see the finger of God is there. Hitherto shalt thou go, and no further, proclaims the God. God himself asked Job this question: who hath shut up the sea with gates, when it brake forth, as if it had issued out of the womb? That the sea is higher than the earth is what men of sound reason lay down for a certain truth. Again, seas higher than the lands. And consequently would overflow the land, was it not stayed by an almighty hand that will not permit that raging element to go beyond its appointed bounds, and makes it recoil back again, even when it threatens the shore with its terrible waves and roars. There was a time when the earth was covered with the deep as with a garment, and had not the providence of God broke up for it his decreed place, it had still continued such a garment to the earth, as the skirt that was made for the murdering of Agamemnon, where the head had no place to get out. I break up for it my decreed place. I set bars and doors, and said, hitherto shalt thou come, but no further. And here shall thou proud waves be stayed, said God. They that go down to the sea in ships and do business in that raging element, these men see the works of the Lord and his wonders in the deep. Or, consider this, from Thomas Vincent's 1673, an explicatory catechism, or an explanation of the Assembly's shorter catechism. Question 7. What is the first argument to prove that there is a God? Answer. The first argument to prove that there is a God may be drawn, let's see, do I need to go another one? Yeah, there we are. May be drawn from the being of all things. And then he mentions the heavens, the earth, that's number 1, the heavens, number 2, the earth, and number 3, the being of the vast sea, where there is such an abundance of waters as some think higher than the earth, which yet are bounded and refrained from overflowing and drowning the land and its inhabitants as once they did when their limits were for a while removed. Now, that catechism was reprinted 1701, 1720, 1777, and 1806. Needless to say, using an idea with roots in the two spheres theory to argue for the existence of God did not work out so well in the long run. As Brother Consamagno says, what is in science books changes. And thus, this strange idea known as the two spheres theory on the shape of our world has taken us from the pages of the De Revolutionibus of Copernicus to a strange mixing of religion and science in the pages of an Anglican catechism. When you start to follow the history of astronomy, you never know through what places the journey will carry you. Thanks.